Hello viewers, this is Wagadarena taking you through the story of A-level applied mathematics, and this video we're going to go through the topic of flow charts. So this topic is under numerical methods and is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. Now before we go any further, let's first look at the progress on this platform. So on this platform, whatever is ticked has been covered, and today we are covering flowcharts, which marks the end of numerical methods, and what will be left will be very few topics, and that is, let me see, topic 1, 2, 3, 4, 5, 6 and 7. So that means that you'll be left with 7 topics in math paper 2. So that, what does that imply? It implies that from this topic we are going to first concentrate on math paper 1 for something like 2 weeks, and so that you can also get a good coverage. So we shall start with flowcharts. Now, a flowchart is an algorithm. So there's this term algorithm given. So this is given to a machine, and a machine can be computer, a phone, etc., to solve a problem. So we have seen two terms. There's the word algorithm and there's the word problem. So what does the word problem mean? So a problem may be finding the sum, mean, power or factorial of particular numbers, and numbers can mean counting numbers, natural numbers, whole numbers, etc., or finding the root of an equation. Now these problems are very vital. This word problem is very vital because when we reach the part of dry run, they will be asking you the purpose of the flowchart, so you must be able to know, is it getting the sum or mean or powers or factorials, etc. So that is what the word problem means. Then what about the word algorithm? So an algorithm is a step-by-step procedure that requires a finite number of steps. So a flowchart is an algorithm, as we shall see it in the preceding slides. You realize that the solution or solving a certain problem has been broken down into smaller and simplified steps. So in a flowchart, all steps needed to carry out an algorithm are broken down into simple elements known as statements, as shown below. So now we have seen the word statement. Now there are 7 statements in flowcharts which are very vital, and let's look at them one by one. So the first statement is called the start statement, and as you can see it follows the shape of an oval. So what is a start statement? A start or begin statement is an instruction to permit the machine to start working, and therefore if there is no start statement, the machine will not start. So in any machine you have to start it. Like for example, if you want your computer to work, you have to first press the on button. So that's what the start statement means. And the second statement is what we call the read statement. So what does this statement do? This statement is an instruction to read the next number in the set of data and give its value to a specific variable. We shall see all that in the worked examples. So that is statement number 2. Statement number 3 is what we call the assignment statement. And the assignment statement is an instruction to substitute particular values into a given formula and then perform the required calculations. Therefore, the operator in this assignment, as you will see in the examples, we shall be using the operator equal to, but this sign equal to does not mean equal to. What does it mean? It means becomes equal to. So that word is very common. This word becomes is very vital, because they can say 2 equal to 2 plus 1, which is not logically correct, but in flowcharts it is correct. Now what I want you to realize is that the shapes matter. The shape for the start statement is an oval. The shape for the read statement is like a parallelogram. Then the shape for the assignment is a rectangle. So the shapes matter very a lot. So that is statement 3. Now we shall go to statement 4. Now statement 4 is what we call the decision statement. And I think you see that it follows the shape of a kite or a diamond. So the decision statement is an instruction that requires a decision to be taken or chosen on the 2 alternatives. This is done by asking a question which requires an answer of either yes or no. So the answer is either yes or no. In other words, there are only 2 alternatives. So the first alternative can be yes or no. So this is one alternative. You can either choose yes or no, and if it is true, if that is what you want, you'll go to the next statement, which is called the print statement. If it is not what you want, you have to go back. But let's first see this option whereby the answer is what you want. If that is what you want, it will take you to the next statement, and that statement is called the print statement. So what does the print statement do? The print statement is also known as the write statement, and in this instruction, the current value of the variable or variables is written down as the final value of that variable. So we shall see what all these ones mean and our worked examples. Now after printing, the next thing is to stop. So the stop statement, what does it do? The stop statement is an instruction to permit the machine to stop where necessary. If there is no stop statement, the machine will repeat the execution of the program endlessly. So for every machine there should be a start statement and a stop statement. Start statement is what permits it to start the work, and stop statement is what permits it to stop where necessary. Now these ones have been the option where one answer is what you want. What if it's not what you want? If the outcome here in this decision is not what you expect, then we do what we call a loop. So the last statement is called the loop statement. This is to help you to repeat the process and be able to come up with what you desire or what you want. So what does the loop statement do? So the loop statement is an instruction that permits the machine to perform long repetitive calculations. As you can see here, it keeps on repeating this assignment until you get what you want. Then when you get what you want, you can go to print and then stop. So now we shall go to what we call dry run. So what we have seen has been the format of a flowchart, and you must be able to memorize the shapes. The shapes matter very a lot. So what is a dry run? We shall come and say that a dry run is the process of obtaining an output from a flowchart given input values or variables. This implies that a dry run gives the output of a flowchart in a table form. So in a dry run, what we want is you to tabulate the output of a flowchart in a table form. And it's from these values that we can state the purpose of the flowchart. Remember, the purpose comes from the problem which the flowchart wants to solve. For example, the problem can be mean or sum or factorials, powers, etc. So the purpose of the flowchart is the relation between the changing values in the dry run. So for you to easily understand the purpose of the flowchart, look at the values which you have tabulated in your dry run and be able to find out the relationship between the given pair. But before we perform a dry run, there is something we need to note, and that is only changing values are put in a dry run. Constant values are put before the dry run. So this is what you need to note. So in your flowchart, look at the values which are changing, or let's say variables which vary. The ones which are constant are not indicated in the dry run. So with that knowledge, you shall be able to go through these questions. Question 1 came from UNEB 2006, paper 2, question 10A, and says, study the flowchart below and answer the questions that follow. Roman 1, perform. So this is the flowchart they want you to study. Roman 1, perform a dry run for the flowchart. And Roman 2, state the purpose of the flowchart. And Roman 3, write down the relationship between n and a. So in this flowchart, this is the start statement, and these are the initial values. This is the loop under the loop. So this loop is what helps you to increment. Then this is what we call the assignment. This is the print statement. This is the decision, and this is the stop. So I think you see that here they have interchanged. They have put the print before the decision. So it's up to the it depends on the desired function of your flowchart for you to put the print before the decision or after the decision. And also I think you see that in the format the loop was here, so this n can be put here or put there depending on the function or purpose of your flowchart. Now for you to know the purpose, you have to first perform a dry run. That is why in the first Roman they told you perform a dry run for the flowchart. So what you need to know is that a dry run contains only changing values. How do you know that a value is changing? If you look at this one, like we said, this equal to under flowchart does not mean equal to, it means becomes. So in this case, we read this as n becomes n plus 1. So that, what does that mean? It means that n is changing, because it was originally n, now it is n plus 1. In other words, it has been incremented by 1. Then this formula shows that this value of a also changes, because when n changes, a will also change. So what does that mean? It means that now we have two variables. So we shall come and tabulate our values for these two variables of n and a. So a flowchart for you to perform a dry run, follow the arrows as they are. Don't interchange and don't assume anything. So from the start, we shall go to these initial values. So initial values, they told us n is 0 and a is 1. So we shall come here and put n0, and where there is a, we shall put 1. Then from this box we shall go to this one. This one means, this one says that n becomes n plus 1. What does that mean? It means that this n, you increment it by 1. So 0 plus 1 gives you 1. So you come here and put 1. Then from this, after that we shall go to this. So we have to follow the arrows as they are. So this one says a becomes. So this one no longer means equal to. That is what you should always remember as long as you are dealing with flowcharts. Otherwise, if this was equal to, it implies that you would cancel this and this, which is vague. So this one means that a becomes a times n. So what does that mean? It means that you come here, this a and this n, multiply the two and be able to get the new value of a. Then from here you go to print. Printing means the output. So they want, what they want are the values of n and a, these ones. Then from there, you go and ask yourself, this is now what we call the decision. The decision has a question, like we said, it has a question which requires an answer of either yes or no. Now you come here and ask yourself, is n less than or equal to 6? Like we said, the question must have an answer of yes or no. And when you look at this value of n, it is true that it is less than 6. Therefore, we shall go where the arrow of yes goes. So the arrow of yes takes you back to this statement. So what does that mean? It means that you increment n by 1. So when I increment n by 1, it was originally 1. So now it is going to become 2. When it is 2, go to this one where you have to multiply this with this to give you 2. Then print and then ask yourself, is n less than or equal to 6? Yes. So you still go back and increment n by 1 to give you 3. Then multiply this with this. That is what this statement says, to give you 6. Then print and ask yourself again. So the process is going to repeat. So I ask myself and the answer is yes. So yes will take me back to increment n by 1 to give you 4. Then multiply that 4 by, multiply this with this to give you 24. Then 24 go to this to print and then ask yourself. When I ask myself, this 4 is still less than 6. So I'll go back here, increment it by 1 to give me 5. Then multiply, this one says that we multiply, so this with this gives you 120. Then I print and I ask myself. When I ask myself, I realize that this one is still under the option of yes. So go back and increment it by 1 again, like that. Then this, from here we go to this where I have to multiply this with this to give you that. Then you print and then ask yourself again. So when I ask myself, this one gives you yes, because they said is n less or equal to 6. It is true. So you have to go back here, increment it by 1 to give you 7. Then from here to this box, you have to multiply this with this to give you that. Then from there you print and ask yourself again. Now here there's something funny. So is n less or equal to 6? Now this one, the answer is no. Hope you realize that, because 7 is greater. Therefore, because it is no, you are going to follow this arrow of no and stop. Now stopping means that you don't continue tabulating more values. That is why you see that my tabulated values stop at n equal to 7. So that is how you can know where to stop in a dry run. So with that, our dry run is complete. Now we shall go to the next part. Roman 2 says, state the purpose of the flow chart. Now you look at what they want to print. They want you to print n and a. So look at this relationship. What relationship is there? Remember, we said the relationship can be sum, mean, powers, factorials, etc. Now if you look at these values, all of them, there is a certain relationship, and the relationship is factorial. For example, 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, and 7 factorial is 504. So therefore, I'll come here and say that the purpose of the flowchart is to compute and print the factorials of numbers from 0 to 7. So you computing is this one, and printing is this. So you compute and print the factorials of numbers from 0 to 7. Then the Roman 3, they want the relationship between n and a. So you come here and say that a is equal to n factorial. So B1 for the column of n, B2, so 2 marks will be for generating this column of a, B1 for the purpose, B1 for the relationship. So that was question 1. Now we shall go to question 2, which came from UNEB 1995, paper 2, question A, and says, perform a dry run of the flowchart shown. What is the outcome in words? After the dry run, state the relationship between capital N and capital T. So like we said in question 1, dry run, you have to look at the changing values. This one shows that N is changing, and this one shows that, remember, A is this, so A is also changing. Then also this, because this A is here, it means that also T is changing. So our dry run will contain 3 variables, that is A, N, and T. So you shall start from the start. Start takes you to these initial values. A is 0, N is 0, and T is 0. So you shall come and do that here. N is 0, T is 0, and A is 0. So we are following this order because of this. The first assignment is for N, followed by T, followed by A. That is why we use this order of N, T, A. So from this, the arrow takes you to this. So this one means that you increment capital N by 1. So N was 0, it is going to become 1. Then from here to here, they tell you that T becomes T plus 6A plus 1. So what does that mean? It means that this T, you put this T 0, you put this A here, 0, and you put this N. Now the new value of N is, okay, here there is no N. So 0 plus 0 plus 1, that means that T will become 1. Then from this you go to this. This one means that A becomes A plus N. So you look at this A and you look at this N. So when you add them, you will come up with 1. Then from there you print, and after printing you go to the decision. Is N equal to 10? This N is not equal to 10, so the arrow takes you to no, and this no will take you and you increment N. So when I increment N, it was originally 1, so increment it by 1 to give you 2. Then from this I go to this, which is T plus 6A plus 1. Now T is 1. Then A is also 1. What does that mean? It means that 1 plus 6 times 1 plus 1. So 1 plus 6 plus 1 gives you 8. Then from this you go to this. A becomes A plus N. So A plus N is 1 plus 2, which gives you 3. Then you print and ask yourself, is N equal to 10? This one gives you no. So the no makes you to increment capital N by 1. So increment by 1, it was originally 2, it gives you 3. Then from here, T plus 6A plus 1. So in this case, T is now 8. Then A is now 3. So 8 plus 6 times 3 plus 1, what does it give you? It will give you 27. Then from this takes you to this, where I have to add A to N. So 3 plus 3 gives you 6. Then you print and ask yourself, is N equal to 10? So this decision takes you to no. So no means that you are going to increment N by 1. So increment N by 1, it was originally 3, it gives you 4. Then go to this. Now T is 27 and A is 6. So therefore 27 plus 6 times 6 plus 1, it will give you 64. Then from this you go to this. A becomes A plus N. So this plus this gives you 10. Then you print and ask yourself. So this decision takes you to a no. So no, you are going to increment. Increment 4 by 1 gives you 5. Then from there, T is 64 and A is 10. So 64 plus 6 times 10 plus 1 gives you 125. Then from this, A becomes A plus N. So A plus N gives you 15. Print and go to the decision. So the decision, this one takes you to a no. So no means that we're going to increment again. So increment 5 by 1 to give you 6. Then from there, remember that T is 125. Then A is 15. So 125 plus 6 times 15 plus 1 gives you 216. Then from this, a becomes a plus n, so this plus this gives you 21. Then print and go the decision. This decision takes you to a no, so no means you increment n by 1, so it was originally 6, it will become 7. Then from there, I'll remember that t is now 216 and a is 21, therefore 216 plus 6 times 21 plus 1 gives you 343. Then from this, I'll go to this where a becomes a plus n, so this plus this will give me 28. Then print and go the decision. Now this decision gives you a no, therefore no means that you increment, so incrementing 7 by 1 will give you 8. Then from there, I'll know that t is 343 and a is 28, therefore 343 plus 6 times 28 plus 1 gives you 512. Then this one means that a becomes a plus n, so this plus this gives you 36. After that, you are going to print and also go to the decision. This decision gives you an answer of no, so no means that you increment again by 1, so incrementing 8 by 1 gives you 9, and 9 from there I will know that t is 512 and a is 36, therefore 512 plus 6 times 36 plus 1 gives you 79. Then from this, I'll go to this where a becomes a plus n, so this plus this gives you 45. Then from there, I will print and then ask myself this question. So this value of n gives you an answer of no, so no means that you increment by 1. When I increment, I'll come up with 10. And after that, I remember that t is 729 and a is 45. Therefore, 729 plus 6 times 45 plus 1 will give you 1000. Then from there, I go to this where a becomes a plus n. So this plus this will give me 55. Then from there, I'll print and then go to the question. So this decision gives me an answer of yes, because it is true that n is equal to 10. So when I go to follow the arrow of yes, it takes me to stop. That is why from this one we don't add on any other value. So that is how you know where to stop on a dry run. You just follow the arrows. Just follow the arrows. So that has been our dry run. Then they told us what is the outcome in words. So before we go to the outcome, let's see marks for this. So B1 for this column of capital N, B1 for this column of capital T, B1 for this column of capital A, all correct. So the outcome, they want you to find out what N is, what T is, and what A is. So you are coming and say that N represents the first 10 natural numbers, then T represents the cubes of the first 10 natural numbers, and A represents the first 10 triangular numbers. Then next we shall go to the next part. So the next part says, after the dry run, state the relationship between capital N and capital T. So we shall come and say that the relationship between capital N and capital T is that N cubed is equal to T. So B1 for setting the outcome, B1 for the relationship. So now we shall go to question 3, which came from UNEB 2008 paper 2 question 2, and it says study the flowchart below. So this is the flowchart they are meaning. Then they said using the flowchart, perform a dry run and complete the table below for x equal to 22 and y equal to 7. So it's the table they want you to complete. Then record P and Q, and then what is the purpose of the flow chart? So we shall start with completing this table. So from the start we go to read x and y. So this x is 22, y is 7. Then from there it takes you to p equal to 0, which has already been given in the question. Then from this we go to this where q becomes x. So q becoming x is 22, therefore q will become 22. That is why you see 22 there. So from here up to here it has been given. Now we are going to start from this onwards. So from this we shall go to the decision, and the decision says, is q less than y? So we know that q is 22 and y is 7. So is 22 less than 7? No. So because it is no, the no arrow is here. So it will take us to this statement. So this statement says you increment p by 1. So p was 0, incrementing it by 1 gives you 1. Then from this it takes us to this statement where q becomes q minus y. Now q is 22 and y is 7. Therefore 22 minus 7 is 15. Then from here it takes us back to the decision. The decision says, is q less than y? Now q is 15, y is 7. So is 15 less than 7? No. Now because it is no, the no option takes us to the part where we have to increment p by 1. So incrementing 1 by 1 gives you 2. Then from here go to this where q becomes q minus y. So 15 minus 7 gives you 8. Then from here you go to the decision. Is q less than y? In other words, is 8 less than 7? No. Because it is no, it takes us to this part where we have to increment p by 1. Increment 2 by 1 gives you 3. Then from here go to this where where q becomes q minus y. So 8 minus 7 gives you 1. Then you go back to from here we go to the decision. Is q less than y? In other words, is 1 less than 7? Yes. Now because it is yes, we go and follow the arrow for yes. And the arrow for yes tells you what? Print p and q. So before we go to the next slide, we shall print p and q. We shall first see marks for this. So B1 for completing column p and B1 for completing column q. Now what does the word printing mean? Printing means that you go and record the value of p, the last value. So this is the last value of p and this is the last value of q. So that's what they want you to record. So we shall come here and say that p is 3 and q is 1. Then what is the purpose of the flow chart? So yes, so the purpose of the flowchart is to find the first 4 terms of sequence or series with first term 22 and common difference -7. So under arithmetic progression, you realize that this is an AP with first term of 22 and common difference of -7. So B1 for this and B1 for that, then B1 for the purpose. So that was question 3. Now shall go to question 4, which came from UNEB 1990, paper 2, question 1b. It says study the flowchart given below, then perform a dry run for the flowchart and hence state the purpose of the flowchart. So this is the flowchart which is given. So the first thing to do is performing the dry run. Performing the dry run means you tabulate the values, and the changing values are n and s. So we're using this order because the first assignment gives you is for s and the second assignment is for n. So we have to start with s followed by n. Therefore from the start we go to s equal to 0. So on s we shall put 0. Then from here we go to n equal to 1. So for n we shall put 1. Then from there we shall go to the next, which says that s becomes s plus n. So this plus this gives you the new value of s. Then you print s and n. So you print these ones. Note that we are printing the diagonal values. Then from there we go to n. N becomes n plus 2. So you increment n by 2. So n was 1. Increment by 2, you come up with 3. Then from there, ask yourself, is n equal to 15? This one gives you an answer of no. So no means that you go and make s to become s plus n. So s plus n means you add this to give you 4. Then from this you go to printing. So you print these diagonal values. Then after that you increment n by 2. So n was 3, so it will become 5. Then from here you ask yourself, is n equal to 15? So this one gives you an answer of no, where you have to go and make s to become s plus n. So this plus this gives you 9. Then from here you print this. Then from there you increment n by 2. So 5 by 2 gives you 7. Then is n equal to 15? This answer gives you no. So no means that you increment. So means that you go back and make s to become s plus n. So this plus this gives you 16. You print and increment n by 2. So 7 by 2 gives you 9. Then is n equal to 15? This decision gives you an answer of no, where you have to go back and make s to become s plus n. So meaning that this plus this gives you 25. Then from here you print and then increment n by 2 to give you 11. Then you ask yourself, and this value of n gives you an answer of no, which here makes you to go back and make s to become s plus n. So s plus n, this plus this gives you 36. Then you print and increment n by 2. 11 by 2 gives you 13. Then from there you ask yourself, and this value gives you an answer of no, where you have to go back and increment s to become s plus n. So this plus this gives you 49. Print and increment n by 2. So 13 by 2 gives you 15. Is n equal to 15? The answer is yes, and because it is yes, this yes takes you to stop. Stop means that you don't continue to add more values in the table. So that will be our dry run. Next is to state the purpose of the flow chart. So you have to look at these values and come up with the purpose. So we shall come and say that the purpose of the flow chart is to compute and print the cumulative sum of odd numbers up to 15. Remember, these are odd numbers and these are their sums. For example, this plus this is 1. I think that you remember that when we are printing diagonal values. Then this plus this gives you 4, like that. So that is why you say sum. Now this word cumulative, what does it mean? The word cumulative depends on where this print is. Remember we said the print can be after the decision box or before the decision box, depending on the desired purpose of the flowchart. Now this flowchart, they wants you to print all these values, so all these values have to be printed. That is why the print statement is there. If this print statement was after this decision, it implies that you would have printed only the last value. Now because they want you to print all these sums, that is why there is this word cumulative. So B2 for the column of S, B2 for the column of N, B1 for the purpose. So that was question 4. Now we shall go to question 5, which says that study the flowchart below. So part A, perform the dry run for the flowchart, and part B, state the purpose of the flowchart. So this is the flowchart given. So they want you to perform a dry run. So you start with a start. From the start we have two variables, s and n, so we shall put n and s. Now here the order is ns because previously in the question 4 the order was s followed by n. Now here it is n followed by s because of the formula. For example, if you look at this, it is n first followed by s. That is why we first put n, then we put s after. So from the start they say that n it becomes 0, so make n 0, and from this they said s becomes 0, so make s 0. Then from here you go to this where you have to increment n by 1, so it becomes 1. Then from here ask yourself, is n a multiple of 3? No. So because it is no, it takes you to this. And here you have to increment n again by 1. So when I increment by 1, I'll come up with 2. I think you realize that this one has been left blank because from here you don't go here, you instead go the option of no. So always be keen to follow the arrow as they are. So after 2, I might ask yourself, is n a multiple of 3? No. No means that you go back and increment n by 1. So when I increment it by 1, it will become 3. So this one is still left blank. Now when I get 3 here, I'll ask myself, is n a multiple of 3? Yes. Now because it is yes, I'll go to this option of yes where s becomes s plus n. So this is the value of s and this is the value of n. Add the 2 to come up with that. Then from here I'll go to this and say says, is n less than 10? So when you look at this value of n here, it gives you a decision of yes. So yes takes you to this arrow, and this arrow makes you to increment capital N by 1. So increment n by 1 gives you 4. Then from here, is n a multiple of 3? This one gives you an answer of no. So no takes you back to increment n by 1. Increment by 1 gives you 5. And this value of 5 gives you here an answer of no. So go back again. Increment n by 1 to give you 6. So this value of 6 here gives you an answer of yes. Now yes means you go here now. S becomes s plus n. Now s is here and n is here. Add the 2 to come up with 9. Then from there, go to this decision, is n less than 10? So this value gives you here an option of yes. So yes takes you back to increment n by 1. So increment by 1 gives you 7. Then this value of 7 here gives you an answer of no. So no takes you back to this. Increment by 1 to give you 8. Then this 8 gives you here an answer of no. So no takes you back, increment by 1 to give you 9. Then this 9 gives you here an answer of yes. So you have from here, you have to go here where s becomes s plus n. So this is s and this is n. Add the 2 to come up with 18. Now from here you go to this where ask yourself, is n less than 10? So this value gives you an answer of yes. So yes means that you go back and increment n by 1. So this 9 will become 10. Then from here go to this, is n a multiple of 3? So this value gives you an answer of no. So no means that you go here, follow this arrow and increment n by 1 to give you 11. Then this 11 here gives you an answer of no. So no means that you increment by 1 to give you 12. Now 12 here gives you an answer of yes. So yes means that you follow this option to where s will now become s plus n. So s is 18 and n is 12. Therefore 18 plus 12 gives you 30. Now from here you ask yourself, is n less than 10? So this value gives you an answer of no. So no takes you to the option of printing s. So printing s means that you come and write it out. That's what they mean by printing. Then from after printing you go to stop. So that is where you stop. That was part A. Now we shall go to part B, where they want you to state the purpose of the flow chart. So the purpose of the flowchart is to find the sum of the first four multiples of 3. So sum of the first four multiples of 3 are, there is this, 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 and this, which will give you 30. So B2 for this column of N, B1 for the column of S, B1 for printing 30, and B1 for the purpose. So that has been the part of performing dry runs. Now we shall go to the next part of drawing flowcharts. So in the previous part, where under dry runs, they draw for you the flowchart and they tell you to perform a dry run. But in this part, you are expected to draw the flowchart by yourself. So here we shall know that flowcharts are usually drawn in any of the 3 forms shown below. So there is a form which has only one decision, where only one decision is needed for you to print. So it will be in this form, which you have already seen. But there are other 2 forms. One is where 2 decisions are taken and both must be fulfilled before printing. So here in this step, this and this has to be fulfilled before you print. That is the format. And the format where any one of the 2 decisions is needed for you to print, this is how it is. So if this decision is fulfilled, you can print, and if it's not fulfilled but this one is fulfilled, you can also print. So that is the difference between these 2. In this case, both have to be fulfilled for you to print, but in this case, if anyone is fulfilled, you can print. So with that knowledge, you shall go to this question 1. So question 1 came from UNEB 2002, paper 2, question 9, and says, given below are points of a flowchart not arranged in order. So these are the statements. Then here they said part A, rearrange them and draw a complete logical flowchart. Then Roman part B, state the purpose of the flowchart, and part C, perform a dry run for your rearranged flowchart by copying and completing the table below. So these ones are scattered, so you have to rearrange them. The easiest way is to first do something, is to first rearrange them in the question paper. So in this part, you shall know that there are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 boxes. So the first thing to do is that the start box is always the first one. So we shall first put a small one here. Before we draw our fully drawn rearranged table, we have to first find out logically how it will appear before we draw the complete one. Now from the start, the second one is to read. So we are going to read. Then from reading, the next will be the assignment. Now the assignment, how do you know? We have 2 assignments. There is this one for C and this one for B. Now how do you know which one will be first? To know depends on this dry run. So dry run from A, they went to B, followed by C. So from A, the first assignment of these 2 has to be B. That is why you have put 3 here. The next is the decision. Why? Because here A minus 5, if B is less than 0, it means that it will be negative. But we don't want negative values, so we have to first go to this decision for you to realize, to find out that this is surely positive. After ensuring that it's positive, what do? You go and ask yourself, can that positive value be divided by 2? And if it is yes, then you can go and get your C, because C is B divided by 2 and we don't want fractions. So you have to first fulfill this condition. First this one that is positive, Next, this one that it is divisible, then from there you can go and divide. So that will be our number 6. Then from number 6 we shall go to number 7 and lastly number 8. Now this one is a loop, and that will be our number 9. So this one is a loop. So when you are drawing, it will be a loop. We first draw the others, then we can put a loop, having a becomes a plus 1. So you shall come and draw as they are. So number 1 was the start, so we shall put our start there. Number 2 was the read. Then number 3 was the assignment of B. Then after that, number 4 was the decision of positive to ensure it's positive. Then it was followed by the decision to ensure that it's divisible. Then after that we shall get the valid assignment for C. Then we can print and we can stop. But there was also a loop to increment A, so we shall put a loop to increment A on both decisions. So that is our fully drawn rearranged logical flowchart. Part B says that state the purpose of the flowchart. So the purpose of the flowchart is to compute and print positive multiples of 2. Alternatively, you can say that the purpose of the flowchart is to compute and print positive natural numbers divisible by 2. That was part B. Now we shall go to part C. Part C said, perform a dry run of your rearranged flowchart by copying and completing the table below. So the given table was that, then you have to complete it. So the starting value is of A is 46, so you come and put here 46. So from there you go here, 46 minus 5 gives you the value of B as 41. Then from here ask yourself, is B less than 0? In other words, is B negative? No. Now because it is no, you go to this. Is B divisible by 2? No. Because it is no, you go to this arrow and increment A by 1. So increment A by 1 to come up with, now this one A becomes, oh yeah, now here they didn't want you to do the dry run yourself, they wanted you to fill these values. So here you just put a dash, there is nothing there. Then you go to the next value of A. So they want you to get the corresponding values of B and C. So here it is dash, then here you go to 77, put your 77 here. Here it will now become 77 minus 5 to give you 72. So 72, you ask yourself, is it positive or negative? Is it negative? No. Because it is no, go here and ask yourself, is it divisible by, is it divisible by 2? Yes. Now because it is yes, you go here and divide it by 2 to give you 36, and there you can print and stop. That is 77. What about for 120? 120, put it here. 120 minus 5 gives you 115. 115, is it negative? No. You go here. Is it divisible by 2? No. You increment it by 1. So there is no value of C, so you just put a dash. Then you go to the one of 177. 177 here minus 5 gives you 172. Is it negative? No. So you go here. Is it divisible by 2? Yes. So you go here and divide by 2 to come up with that. So basically that's what they wanted. So B1 for the start and read statement. Then this one is for assignment of B. Then this one is for the first decision. This one is for the second decision. This one is for the assignment of C. This one is for the print and stop statement. Then this one is for the loop, and B1 for the purpose. B4, B, C, and B. So this one is for each row. One for that, one for that, one for that, and one for that. So that was question 1. Now we shall go to question 2. Question 2 came from UNEB 2012, paper 2, question 14b, and says, a shop offered 25% discount on all items in its store, and a second discount of 5% to any customer who paid by cash. Roman 1. Construct a flowchart which shows the amount paid by each item. Amount paid for each item. Then Roman 2. Using your flowchart in Roman 1, compute the amount paid for the following items. So let's start with Roman 1 of drawing our flowchart. So yeah, we're going to first select some parameters. So let A denote amount paid for the item, and P denote the price for the item, then C denote the credit payment. So always the flowchart starts with a start statement, then followed by read. So you have to read the price of the item. The next is to compute, because they told us that a shop offered 25% discount on all the items and a second discount of 5% on any customer who paid by cash. So this 125, whether you paid by cash or credit, you are given a discount of 25. So the new price will be 100 minus 25%, which is 75%. So 75% of the original price of the item. That is why here you see 75% is 75 100. That's why you see 0.75p, where p is the original price of the item. Then from there you have to ask yourself, is payment by cash? So if payment is by cash, you are given another discount of 5%, but that 5% is removed, is deducted from this new price. That is why 100 minus 5 gives you 95. So 95% is 0.95. Now that 0.95 is of this new price. That is why you see here A is equal to 0.95C. And there you can now print the price, print the amount paid for the item, and you can stop. But the question is, what if payment was by credit? In other words, what if it was not by cash? What does that mean? It means that you don't get the second discount, you only get this first discount. That is why here now we shall say that amount is equal to this, is equal to that value of C, and that is what you print as the amount of the item. Part B says that using your flowchart in Roman 1, compute the amount paid for the following items. Mattress at the price was 125,000 and payment was by cash. So that means that the value of P is 125. Therefore, from here we shall go here which says that C is equal to 0.75p, but the amount they want is this. So this amount is 0.95c, which is there, and our C is got from here, and in this case P has been given as 125. So we shall come here and substitute and be able to get the value as 89,062.5 shillings. What about for the television set? For the television set, here it was 340,000 and it was by credit. So by credit, it means that A is equal to C, but C is 0.75p. So you come and substitute for P to come up with shillings, 225,000 shillings. So B1 for the first three statements, B1 for the next three, these ones, then B1 for the print and stop statements. Then this M1 for this substitution, A1 for the output, M1 for this substitution, A1 for the output. So that was question 2. Now we shall go to question 3, which came from UNEB 2006, paper 2, question 10b, and says, draw a flowchart that reads and prints the mean of the first 20 numbers and perform a dry run for your flowchart. So always the first thing to do is the start statement, then followed by the initial values. N is 0 and also S is 0. Then go to the assignment, you increment N by 1. Or incrementing N by 1, you can get the new sum. Then from the new sum, you ask yourself, is N equal to 20? If it is yes, you go and print what you go and get what they want, and that was the mean. So this S is the sum, and this one is the number of terms. So here, if N is 20, because they want the mean of the first 20, so if N is 20, you go and get, if there is number of terms are 20, you can get your mean and then print that mean, and you can stop. But the question is, what if N is not equal to 20? You have to put a loop and increment the value of N. So we're going to put a loop there like that for the option of N not equal to 20. So basically that was the flowchart, but they also wanted you to perform a dry run. Now here you realize that they just said 20 numbers. They didn't specify whether counting numbers or natural numbers. Now because they didn't specify, that is why you see here 0. But if they had specified that counting numbers, we would have begun with 1 1 there. So the variables are N and S. Now the order is because of the assignments. Here it is N followed by S. That is why here it is also N followed by S. So we are going to start. I believe now you are well versed with performing dry runs, so we shall be a little faster. So from the start, N is 0, S is 0, so we'll come and put 0 0. Then from there, increment N by 1 to give you that. Then get the new value of S. Then ask yourself, so this one gives a decision of no, so you go back and increment. When you increment, you get 2, and the new sum will be 3. This one gives a decision of no, so no say that you go and increment. When you increment, you get 3, new sum will be 6. This one gives a decision of no, so no means you go back and increment. When you increment, you get 4, new sum will be 10. This one gives you a decision of no, so no means that you go back and increment. When you increment, you get 5, and new sum will be 15. So this one gives you a decision of no, so no means you increment. When you increment, you get 6, new sum will be 21, and this one gives a decision of no. So you increment to get 7, new sum is 28. This one gives a decision of no. Increment to get 8, new sum is 36. This one gives a decision of no. Increment to get 9, new sum is 45, and that one gives you a decision of no. Increment to get 10, new sum is 55, and that one still gives you a decision of no. Increment to get 11, new sum is 66. This one gives a decision of no. Increment to get 12, new sum is 78, and that one also gives a decision of no, so you still continue. So continuation. Now this is because my table could not fit in on my page, that's why I put the word continuation. But if yours can fit, you just continue with your table. So when I increment, I'll come up with 13, and new sum is 91. This one still gives you a decision of no, so increment, you get 14, new sum is 105. That one still gives you a decision of no. Increment, you get that, new sum is that, and this one gives you a decision of no. Increment, you get that, new sum is that. This one gives you a decision of no. Increment, you get that, new sum is that. Still, that one gives you a decision of no. Increment, you get that, new sum is that. This one gives you a decision of no. Increment, you get that, new sum is that. This one gives you a decision of no. Increment, you get that, new sum is that. So this one gives you a decision of yes. So yes, you go and calculate your mean. So you'll come and say that mean is equal to that. Then from there, you can now print and stop. So basically, that is what they wanted. So B1 for the first 5 entries. These ones 1, 2, 3, 4, 5. So that is B1, all correct. This one for the last 4, 1, 2, 3, 4, with a loop seen. So this loop has to be seen. Then B1 for the column of N, all values correct. B1 for the column of S, all values correct. B1 for the mean. So that was question 3. Now we shall go to question 4, which came from UNEB 1990, paper 2, question 1C. Draw a flowchart for computing and printing the mean of the square roots of the first 100 natural numbers. So here, this term should not scare you, whether they say square roots or cube root or squares or what. The flowchart, the appearance of the flowchart will be the same. It's only the assignment which will change, as we are going to see here. So let S denote the sum and N denote the number of terms. So always start with the start, then go to the initial values. Now here they specified natural numbers. That's why you see here N equal to 1 and S equal to 1. Then increment N, get the new sum. Now this is what I was telling you. When they put your square root, that's when you put your square root. If they have put cube root, here I would have put a cube root sign. If they have put a squares, here I would have said N squared like that. If you have put cubes, here you put N cubed, as we shall see in the next question. So after the assignment, you can go to the decision. Is N equal to 100? If it is yes, you go to calculate your mean and then print that mean and stop. But what if N is not 100? You have to increment N by putting a loop there. So I'll come and put my loop there, and that'll be my complete flowchart. These were the first 3 statements. Next 2 entries, these ones, decision with loops in, assignment for mean, print and stop statement. So that was question 4. Now we shall go to question 5. Draw a flowchart to find the sum of the tubes. Now here they have used the word tubes of the first 20 counting numbers. So like I said, the appearance will be the same. It is only the assignment statement which will change in the formula. So we start with start, put initial values. Because they said counting numbers, you start with N equal to 1 and S equal to 1. Then increment N, get the new sum, then ask yourself. Now I think you realize here that I've only interchanged. If you compare this with the previous flowchart in question 4, here there was a square root, but here there is now N cubed, because here they said tubes. So always the flowchart will be the same, but it is only this assignment which will change. So here they only want sum, they don't want mean. That is why you, after getting S, you can print S. When N is 20, you can print. But what if it is not? You have to increment N by putting a loop there. So you shall come and put a loop there. After the stop, you can come and put the loop there. And that will be the complete flowchart they wanted. So B1 for the first 3 entries. This one is for this incrementing, assignment, decision with loops in, print and stop. So we have seen how to perform the dry run and also how to draw some flowcharts. Now we are going to deal with some flowcharts which involve Newton-Raphson method. So this formula Newton-Raphson method was already covered in the previous video of relocation and approximation. So I believe you already viewed that video, and now we shall be applying it under our flowchart. So the main objective of this section is to broaden our knowledge on the process and to acknowledge the use of flowchart in this method. So by this, the word method, I mean Newton-Raphson method. In using this method, the main aim is to decide on how many iterations should be performed before being confident of the accuracy. A standard procedure is to compare consecutive pairs of approximations until their difference is below the acceptable level. Now that level is known as the tolerance level. So this tolerance in this case acts as a counter check before accepting a result to be printed, and a counter is used to stop the iteration. So we shall see under the examples how this tolerance is used. I believe you're already aware of this word because we also covered it under root, location and approximation. So now we shall start with question 1, which came from UNEB 2015, paper 2, question 14, and says part A, show that the iterative formula based on Newton-Raphson's method for approximating the root of the equation, this is given by this expression where n starts from 0 to 1, 2. So this is supposed to be 2, not 3, and so on. So I think let's start with part A. So first of all, we are given that equation is what becomes our fx. I think we realize that we don't put xn here, we only put x. The next is to differentiate that function. When I differentiate 2 ln x, I'll come up with 2 over x. I think you saw that under further integration, and that video is also on this platform. So differentiate x gives you 1, so this negative is maintained. When I get this into one LCM, I'll come up with 2 minus x, everything divided by x. After that, I'll code the formula for Newton-Raphson method, then I substitute. Now it is at this step that we use xn. So always remember that in these first 2 lines, we only use x. Then after quoting the formula, that's when we start using xn. Next is to combine into one quotient by getting LCM. So LCM is this. After that is I'll collect like terms. When I collect like terms, you realize that this and this cancels. Then this with this, you remain with 1xn, which is that. Then the whole of this remains, which is that. Denominator, the whole of it remains, which is that. Then next is to rearrange in the format which was required in the proof. So to do that, in the proof, this was positive. So I have to multiply up and down by -1 to come up with this. So in this case, ln has been made positive, and basically that's what they wanted. So we shall come and conclude that xn is equal to this required proof. So remember, this is 2, not 3. So M1 for substituting, M1 for combining to one quotient, B1 for the required expression. So that was part A. Now we shall go to part B. Part B says draw a flowchart that Roman 1 reads the initial approximation x naught of the root. Roman 2 computes and prints the root correct to 2 decimal places using the formula in A above. So the reading part, they only want you to read x naught. Then computing, we shall compute using this formula. Then printing, they want you to print the root, which is xn plus 1. Therefore, we shall come here and say always before anything you have to start with a start statement. Then from the start statement, you shall go that to our initial value, which is n equal to 0, because you start with x naught. Then from there you can be able to read your x naught, which is the initial approximation. After reading, they told us to compute. Computing is an assignment, so the formula we are given is what we shall put in that assignment statement. So you must be keen with the shapes. The shape for read is a parallelogram, you don't interchange. The shape for start is an oval, so you don't interchange. And the shape for assignment is a rectangle, so don't interchange. Then from there, we shall now ask ourselves, is the error less than the tolerance or not? So now this is what we call the tolerance. Because they say 2 decimal places, it will be 2 zeros. I think you remember that explanation under root location and approximation. If it is yes, then you can go ahead and print the root. So the root is what is this xn plus 1. That is what they call the root. And in the question they told us to print only the root. After printing the root, you can go ahead and stop. So now the question is, what if this error is greater than the tolerance? It means that we have to go and increase the number of iterations and then compute again. Therefore, we shall come and draw our loop statement where we increase the number of iterations, get the new root, and then compute again. So by increasing the number of iterations, we shall go ahead and increase the number of iterations, then get the new root like we did under Newton-Raphson until this error is less than the tolerance. So when it is less than the tolerance, it will give you an option of yes where you can go and print. So basically that is the flowchart they wanted. So now we shall go to part C. In part C, they told us, taking x naught as 3.4, perform a dry run to find the root of the equation. So before you tabulate your values, you must first look at this read statement. Whatever they tell you to read here is what you first quote. Now they told us to read x naught, so you come here, before you tabulate you have to quote what they told you to read, and that was x naught. Then after that we can now go and tabulate our values. The changing values, we have n, we have xn, we have xn plus 1, and also this difference. That is why there are 4 columns. So the first one will be for n, the second one will be for xn, the third one will be for xn plus 1, and the last one will be for the error. But remember, there is a magnitude sign here to eliminate the negatives. So we shall start when start with n equal to 0. So put your 0 there. Read x naught, so come and read this value, put it there. Then calculate. From here you go here where you have to calculate. So what does that mean? It means that you substitute this value of 3.4 where there is xn, here, here, and here. When you do that, you'll be able to come up with 3.5155. Now I think you realize that I'm using 4 decimal places because the tolerance, the accuracy was required to 2 decimal places. Now when the accuracy is to 2 decimal places, like we have already said, you add 2 more decimal places. So this was 2, so I can add 2 more decimal places to get 4 decimal places. So you either add 2 or you add 1 decimal point. So at this column we need our values to either 3 decimal places or to 4 decimal places. Then from there I'll come and subtract this and this. The difference between the two will be that they only want the magnitude. Now the question, from here I'll go here, this is where this column comes in. Now the question is this value less than 0.005? Of course no. So because it is no, you'll come and follow your arrow for no, which takes you to increase the number of iterations. So it was n0, so it will be incremented by 1 to become 1. When it is 1, now it means that here I'm going to get what was x0 will become x1. Therefore this is now the value we are going to come and substitute here. When I substitute where there is xn here, here and here, I'll be able to get my xn plus 1 as 3.5129. Then from here I have to go here, so I have to first get this difference. So when I calculate the difference, it will be 0.0026. Then I ask myself, is 0.0026 less than 0.005? The answer is yes, so you go to follow the arrow for yes, where you have to print the root. So printing the root means you come and state, so you come and say that the root is 3.51 to 2 decimal places. So at the very end, that is when you round off to the required number of decimal places. This one was 3.5129. Rounding it off to 2 decimal places gives you 3.51. So B1 for the first 3 statements with the correct shape. B1 for the assignment with the correct shape. This B1 for the decision statement. This B1 for the loop back statements. This one for the print and stop statements. Then B1 for xn, column of xn with values greater than 2 decimal places. B1 for xn plus 1 with values more than 2 decimal places. B1 for the difference. Then B1 for the required root. So that was question 1. Now we shall go to question 2, which came from UNEB 2003, paper 2, question 12, and says Roman 1, determine the iterative formula for finding the 4th root of a given number capital N. So I think let's start with Roman 1. So 4th root means that 4th root of n is n to power 1 over 4, which is given by this. So what I'm going to do, I'll put powers of 4 on both sides to come up with x power 4 here. Now here the power of 4 with this 4th root cancel to remain with only n. When I put everything on one side, I'll come up with this, and when this is equal to 0, it means that this other side is what is our fx. So we'll come here and say that fx is equal to this, implying that the derivative is 4x cubed. Then from there I will quote the formula for Newton-Raphson method and then substitute. Now it is at this step that we use xn. At this point we don't use xn. At this point we have to use xn. So always remember that. So when I substitute for fxn and f prime xn, I'll come up with this. Combine into one quotient to come up with this. Simplify, so this is 4xn to power 4 and minus xn to power 4 to come up with 3xn to power 4. This minus and this minus gives you a positive, then this n remains there. Here the denominator remains the same. But now next is to express this xn plus 1 in the required format. So what we are going to do, we are going to first split the numerator to come up with this over this, which is here, and this over this, which is here. Then you realize that I can pull out 3 over 4 because in the required format 3 over 4 was outside. So when I pull out 3 over 4, here 3 over 4 will go out, then this and this are remaining with 1xn, which is there. Then for this term, there is no 3 here, so it means that it has to go down here. Then this n is here. This 4 already went outside, so this here remain with only xn cubed, which is there. So basically that is what they wanted in this Roman. M1 for this substitution, B1 for combining into one quotient, B1 for the required format. So that was Roman 1. Now we shall go to Roman 2, where they say draw a flowchart that reads capital N and the initial approximation x0. So here, unlike in the previous question, they only wanted you to read the initial approximation, but this question they wanted to read both the initial approximation and capital N. Then after that you compute and print the fourth root of capital N correct to 3 decimal places. So let's first do that. So before anything, we have to start with a start statement, then go to the reading starting by n equal to 0 because you have not yet performed any iteration. Then from there, you can now read the value of initial approximation and capital N. So in this part of read, you only read what has been told. Then you go to the assignment. Assignment, that's where you put the formula you have derived. Now after computation, next is to check the tolerance. So they told us 3 decimal places, that's why you see here 3 zeros. Then if yes, then you can go ahead and print the fourth root, and after printing you stop. But the question is, what if this error is greater than the tolerance? It means that you have to increase the number of iterations and then compute again. So you come here and put a loop where we have to increase the number of iterations and then compute again. So basically that is what they wanted. Now let's go to Roman 3. So Roman 3 says perform a dry run for capital N equal to 150.10 and x0 equal to 3.200. So before you tabulate, the first thing to do is to look at this read statement. So you have to first quote what they want you to read. They want you to read n, so you have to quote n. They want you also to read x0, so you have to quote x0. Then after that, we can now tabulate. We have 4 variables. There is n, there is xn, there is xn plus 1, and there is also this error. So you put a column for n, a column for xn, a column for xn plus 1, and a column for the error. Then we shall start with n being 0. Then when n is 0, we have here to become x0, which is 3.2000. Then after we shall come and substitute this xn in this expression where there is xn here and here to come up with xn plus 1 being equal to 3.5452. Then subtract the 2, you'll come up with 0.3452. So when I subtract here, it gives me an answer of no, so I have to go and increase the number of iterations by 1 to come up with 1. That means that now the new value of xn will be 3.542, which is here. Then get this one and put it where there is xn here and here to come up with 3.5012. Then the difference will now be 0.0440. This difference here gives you an answer of no, so you have to increase again the number of iterations by 1 to give you 2. And that means that now the new value of xn is this. Then get this value, put it here and here to come up with 3.5002. The difference will now be 0.0010. Then this answer, put it here, it gives you an answer of no, so you have to increase the number of iterations. When I increase, it will become 3. That means that this value will now come here to come up with that. Then substitute this into this formula to come up with that. Then the difference will be 0.0000. So put this difference here, it gives you an answer of yes, so go and print xn plus 1. Therefore, you'll come and say that the root is 3.500 because they wanted the answer to 3 decimal places. So you have to come and round off this value to 3 decimal places, which gives you that. So here, B1 for the first 3 statements with the correct shape, B1 for the assignment, B1 for the decision, B1 for the loop statements, and B1 for the print and stop statements. Then here, B1 for the column of xn, but values should be greater than 3 decimal places. B1 for the column of xn plus 1, but the values should be greater than 3 decimal places. B1 for the difference. Then B1 for the required root. So that was question 2. Now shall go to question 3. Question 3 says, Part A, derive a formula based on Newton-Raphson method for finding the reciprocal of a number capital N. So I think let's start with that. So reciprocal means that x is equal to 1 over n. Then after that we shall put reciprocal on both sides. That means that this one becomes 1 over x and this one becomes capital N. Then take everything on one side to come up with n minus 1 over x equal to 0. Because it is equal to 0, it means that this is our fx. So you come and say that fx is equal to that, which is the same as this based on laws of indices. Then we differentiate to come up with that, because differentiating a constant is 0 and differentiating this gives you that. Then after that we shall quote the formula for Newton-Raphson. Then we substitute for fx and fxn and f prime xn, combine into one quotient, then open brackets and simplify to come up with that. After that we need to express in the required proof, which is that. So here what I've done, I've opened brackets, so this one multiplied by this one, it is same base, add the powers, you remain with the negative 1 plus 2 gives you positive 1, that is why there is xn here. Then this times this gives you nxn squared. Factorize out xn, you come up with that. And basically that's what they wanted. So B1 for this substitution, M1 for this substitution, M1 for combining into one quotient, B1 for the required expression. So that was part A. Now part B says design a flowchart that Roman 1 reads the initial approximation and N reads x0 and capital N. Then Roman 2 computes and prints the number and its reciprocal after 3 iterations, or this word or gives the reciprocal correct to 3 decimal places. What does that mean? It means that there are now 2 decisions. One is for the accuracy and another one is for the number of iterations. I think you remember that when we are starting drawing flowcharts, we saw three forms of flowcharts: one where there is only one decision, and two where there are both decisions and both are needed, and three where there are both decisions but one is needed for you to print. So in this case, there are two decisions but one is needed for you to print, so we shall use that format which you already saw earlier. So always start with the start, then go to initial start, which is n equal to 0, then start reading the initial approximation and the value of capital N as we are told in the question. After that, you go to the assignment where you feed in the formula which you derived. After that, we shall go to the first decision, which deals with accuracy or tolerance. Then if yes, you can go ahead and print the number and its root, and then you stop. But they also gave us another decision of the number of iterations. So if this is not fulfilled, you can go ahead and check on the number of iterations. If the number of iterations is correct, then you can is equal to 2, then you can go ahead and also print. So I think you can see that if this one is not fulfilled and this one is fulfilled, you will still print. So that's what I meant by two decisions are given, but any one of the two, if any one of the two is fulfilled, you can print. Now the question is, what if both are not fulfilled? There you have to go and increase the number of iterations and then repeat the computation. Therefore, we shall come and put our loop back where we shall increase the number of iterations and then compute again. So basically that is the flowchart they wanted. Now let's go to part C. Part C says, hence perform a dry run for your flowchart taking capital N equal to 7/6 and x naught equal to 0.8. So before tabulating, look at this read. They want you to read capital N and x naught, so that's what you first quote. And you say capital N is 7/6 and x naught is 0.8. After that, you will now go ahead and tabulate. So tabulating, we have n as a variable, capital N is a constant, but we have xn as a variable, xn plus 1 and the error. So we shall come here in our table and put small n, xn, xn plus 1 and the error. The starting part of n is 0, so we shall put here n equal to 0. When it is 0, here to be x naught, which is 0.800. So they want two decimal places, that's why we use more than 2. Then when I substitute this one, where there is xn, I'll come up with 0.853. The difference between the two will now be 0.053. Put this one in this decision, the answer will be no. And when you go here, n is not equal to 2, so the answer is still no. Therefore, you have to go and increase the number of iterations and then compute. So when I increase, it will be 1. So when it is 1 here, I'll come and bring this one here to come up with that. So this is our new value of xn. So get this xn and put it here and here to get the new value of xn plus 1, which is 0.857. Then the difference between these two will be 0.004. Put this decision here, it will give you an answer of yes. So you'll have to go here and then print what is required and stop. That is why we stop at n equal to 1. Then after printing means that you print what they want, n is that and xn plus 1 is that. So B1 for the first 3, then B1 for the assignment, B1 for the decision, B1 for the loop, B1 for the print. So decision is both these decisions, then this print and stop statement. Then B1 for the column of xn, but the value should be greater than 2 decimal places. B1 for xn plus 1, but the value should be greater than 2 decimal places. B1 for the difference, and B1 for the required root and value of capital N. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be now on the pending mechanics topics, because we have finished numerical methods and we have also finished probit and statistics. So the part which is remaining under math paper 2 is some bits of mechanics. So those will be the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit as a family.